Hello everyone. So today we are going to discuss the third question of the recently concluded Codeforces round 840. So another it is the question another array problem. Let's see what the question actually is. We are given an array of n integers. We are allowed to do the following operations on it as many times as we want, and what we need to do is maximize the sum of the array of the final array that we can obtain by doing such operations. So the operation is you can select two indices I less than j and replace all the array values with indices in I to j with value mod of ai minus aj. So let's see through an example what it actually means. Suppose we are given an array. Suppose I'm saying A, B, C, D. These are the elements. Let's say we select this I, select this J. Another element is there. Then what will we do is replace all these elements with mod of B minus D. E remains C. So B becomes B, C, D all become mod of B minus D. Fine. I think you everyone got what the operation means. So what we need to do is maximize the sum, right? So I will show you something like it will help you in solving this problem. Like it is a I found this through observation. Let's see it. Suppose again an array of size 4 is given, that is A, B, C, D. I think everyone remembers that we need to maximize the sum of the array. So we need to somehow try to maximize the elements or try to maximize the maximize is I mean manipulate the array in such a way that the sum of the array gets maximized, like it gets more than a plus b plus c plus d. Okay, so let's try to do it. So let's say this one is the maximum element. Okay, so what we will do, select these two indices I j. So what will it become? Mod of a minus b, mod of a minus b, c, d. Then again we will select these two indices. Then what will it become? 0 0 c d, right? Now what we will do is, oh sorry, yeah. So what we will do is select this one and this one. And then what will it become? You see, the trick is here only. All will become c, all these three. Now sorry, space shortage. Now I'm going here, c c c d. Now we are going to select these two. What will it become? Mod of c minus d, mod of c minus d. Again we do the same. 0 gets induced here, c c 0. Now we select the whole array. So what will it become? Mod of c minus 0 or c. Let's do it. It becomes c c c. Yeah. So that what is the sum of the array is 4 into c. This is it, right? Let's check another. Let's say the maximum element was here. This is the maximum. Sorry. This is the maximum. then it will be easier for you to understand more, right? We will select this one and this one. It will become mod of p minus t, mod of p minus d, and mod of p minus t. Again we will select these two, so it will become top 0 0 0. Now we'll select the whole array, so it will become a a a a. Yeah. So you get it, right, that wherever the maximum element is, we can always make all the elements equal to the maximum element of the array, because I did it here last time. This one and this one are symmetric, and this one and this one are symmetric positions. Symmetric positions, right? So whatever is the case, if it is an array of size 4, we can always make all the array elements equal to the maximum element of the array. Now what conclusion can we draw from here? That is the question. The conclusion is, if we are given an array of size greater than or equals to 4, we can always make all the elements equal to the maximum element of the array. Means, suppose a1, a2, a3 dot 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 dot, ai to an. These are n elements. If n greater than or equals to 4, you can always make, say, ax max element. We can always just make all elements equal the maximum element. So how is this helpful? So this actual maximum is this the sum, right? The sum of array equals to n into max element array, right? So this means wherever the position of ax is, suppose it is at the leftmost end or at the rightmost, it is very easy. If it's present here, if the maximum element is present here, then you will make all the elements from a2 to an equals to, first we will make all the elements equal to mod of a2 minus n. Then you will again apply that operation at those two indexes only, that it will become all those elements a2 to an will become 0. Then you will select the whole array, so that the whole array elements will become equal to a1, that is the maximum element. And suppose it is this element, right? I will take this case only, it will be more clear to you. Let's remove it. Yeah, this is the maximum element. Then we will select either the left part or the right part. sorry. Yeah, so either we'll select the left part or the right part, whichever has more elements. Okay, in this case, suppose we are assuming that this one has more elements. We will apply the operations in this index and this index, a of x minus 1. So it will become mod of a of x minus 1, 1 of x minus 1 to ax to an. Again we will do the same on this and this, so all will become 0, right? Think you are getting it. 0 0 0 0 dot 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 ax dot 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 an. Next we select this one and this one, it becomes ax 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 dot 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 x minus 1 at the index will also become a x, and this one is ax to x minus 1 at index. Now the job becomes easy for you. Yeah, since you have x, so many x's there, you can select this part. It will become mod of ax minus an to mod of a ax minus an. Again you apply the operations here, so all the elements between these will become 0. Then we select the whole array, so it becomes ax 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 ax, right? So sum is maximum sum is n into ax. Ax is max element. Yeah, so in this way we have proved that if the size of the array is greater than or equals to 4, the answer will always be equal to the sum, maximum sum will always be equal to n into maximum element of the array. So let's write, okay, I will write it later. Let's check the other case too. So we have considered n greater than or equals to 4, so the only cases left are n equals to 3 and n equals to 2. Well, n equals to 2 is a very trivial case actually. You can check it like the sum will either be maximum of sum of initial array comma sum of 2 into, sorry, abs of 2 into a0 minus a1. I've taken 0 index like you will do in while writing the C++ code actually. That's that's what I've done. So the if n equals to 2, then the array elements will be a1 a2. The only operation we can do is select this one and this one, because there are two indices and I should be less than j, so there are only one possibility, so it will become at max mod of a1 minus a2 mod of a1 minus a2. You won't do, obviously won't do the operation again on this two, because then it will become 0. So how it will get maximized, right? So the answer will be max of a1 plus a2 comma 2 times mod of, yeah. So this is the case for a1 plus sorry, for array of size 2. You get it? So we have discussed this one too. So the only case left is n equals to 3 of array of size 3. This will be also similar, just a few edge cases. Suppose the array is a1, a2, a3, a3. So initially the array sum will be a1 plus a2 plus a3, right? So what operations can we do? We can again try to do that operation what we did in n greater than equals to 4. First select this one and this one. So what will it become? A1 comma a1 mod of a2 minus a3 mod of a2 minus a3. Again do the operations here. It will become a1 0 0. You can again select the whole array now. a1 a1 a1. So the sum is 3 times a1. Similarly you can wait a minute. Similarly you can choose this one and this one, so it will become mod of a1 minus a2 mod of a1 minus a2 and a3. Then you can select these two, it will become 0 0. Then select the whole array, it will become a3 a3 a3. So the sum is 3 of a3. We got 3 cases. I will write it down here. 3 of a1, 3 of a3. These are the few of the manipulations we can do now. Yeah, again check a1 a2 a3. Now another the operation a1. Initially what we did actually, mod of a2 minus a3 of a2 minus a3. So another sum can be summation of this whole array, right? What is that? a1 plus 2 into mod of a2 minus a3, right? Check this, a1 plus 2 into 2 into mod of a2 minus a3. Similarly we can choose these two. What will it become? Mod of a1 minus a2 mod of a1 minus a2 and a3. So the sum will become mod plus a, yeah, mod of say plus a3. These are the few cases we have considered. Now there is one last edge case to be considered. Okay, a1 a2 a3, that's it. Now we again do the same operations. Take this one, again take this one like we did in the case n greater than equals to 4. then we will sorry, what I'm not this one, we will take these two this time. So what will it become? Mod of a2 minus a3, mod, here it will be mod of a1 minus mod of a2 minus a3 mod, and here it will be mod of a minus 3, 3 as it is. Now it is will become, you can select these two indices, what will it become? These are same, so it will become 0, right? 0 0 mod of a2 minus a3. Now we select the whole array, it will become mod of yeah. So what's the sum? It will be 3 of into mod of a2 minus a3, right? Another case is that I will not derive it, you can prove it yourself. It is the symmetric part of this actually. Select this one, it will become mod of a1 minus a2 a3. Again select this one, this two, it will become mod of a3 minus mod of a1 minus a2 on both the sides. Again we will apply the operations in these two index, it will become 0. Then you select the whole array, it will become, I am writing 3 into a1 minus a2. So these are the only edge cases that you need to consider, right? So let's write all of the edge cases down. Okay. So we have done this one too, right? So only in the n equals to 3 there are too many edge cases actually. So yeah, lemma, I like to write that actually, that's why I'm writing lemma 1. If n, that is the size of the array, is greater than equals to 4, the answer is sum, I will write max sum sum is n into max element of array n excuse me, equals to 2, max sum equals to maximum of a1 plus a2 comma 2 times mod of a1 minus a2. That is I had proved, you can replay back and check. And 3, if n equals to 3, and then there are these edge cases, max sum equals to, I'll write it in red so you can understand better, maximum of a1 plus a2 plus a3 comma 3a1 3a3 3 into mod of a2 minus a3 comma, sorry, yeah, these are the only cases. Now few people might say that the case 2 case 1 and case 3, that is the n equal greater than equals to 4 and n equals to 3 are same, but it is not actually, because if the maximum element is the is at a1 or a3, we can surely induce it in all the elements of the array, but if it is at the middle index, that is a of 2, we can't. See, you can't induce a2 in all the indices. You can check. See, we could do a3 and a1 and a3, but not a2 in any of the cases. You can check. So, but please bear me for my handwriting, it is a bit bad. So yeah, this is it. Please like, share, and subscribe the video if you liked it, and comment down below if you have any issues with the question. I will definitely try to resolve it. Oh, sorry, I forgot to show you the code. Check it out. Yeah, this is what I did. Inputted the array. If n greater than equals to 4, I output maximum element of a into n. It is a stl, you should know. And in case 2, answer is maximum of answer comma 2 into mod of a0 minus a1 or a1 minus a2. I took 0 index, you can take a1 index vary 2, and in case 3, all the edge cases of n equals to 3, you can check. So what's the time complexity at the worst case? Time complexity will be O of n, because we, if n greater than equals to 4 it is given, we need to traverse through the elements of the array, and space complexity is, excuse me, is O of 1. Okay, I think you get it. So let's wrap up this video here.